So the next question is, what is the output of the below code? So we have four integer variables, a, b, and xy. A, b is of value 127, xy is of value 128, and there is some comparison happening. So let's understand this in detail. Here in this example, right, we have four integer variables, and first two are valued 127, second two are 128, and we are trying to compare these variables using double equals. First of all, comparing double equals, right? It will just compare the object address or reference. But here what is happening? So when I do this comparison of A equals to B, here I'm getting true, but here I'm getting false. Let's say if this was something else, maybe for example, I'll take two more things. So maybe I will name it as 126 and 126 also. And here I'll compare with C and D. So first two will return true. The last one will return false. We'll see the result first. After that, we'll understand why. So first two is returning true, but last one is returning false. Why? Because all of them are doing the same comparison only. Ideally, double equals is not used for the object comparison, but we are doing it. It is working here. So why it is working is whenever you assign some value to an integer. So when you go inside this integer class, it uses value of method where what it does is if the value is within the range of minus 128 to plus 127, then it will cache the value. So there is an integer cache. So whenever you try to assign a value to an integer, what it does is if the value is between 128 minus 128 to plus 127, it is served from the cache. So it will not create a new object. If you see the clear case here, so it will take low and high. So this is basically minus 128. This is basically 127. And if it is within this range, it will return the cached object. So if I go here integer cache, it will basically return this integer cached object. I hope it's very clear to you. So because of that, what is happening is when you initialize with 127, 126, we'll get the cached object. So even for A equals to 127 and 127 of B, so both of which will get the same object. So here also it's the same thing. Here also, here the problem is it is 128. Cached value range is what? It is minus 128 to plus 127. But this plus 128 is not in this range. So we'll get two different objects for x and y here. When you do double equals, we are getting false. So the ideal way to compare is using dot equals. Dot equals we have to use. This is foolproof of any value range. So this is what we have to do. And here if I have to add the same thing. So here also I've used dot equals. Now I should get true for all. Okay. So this is working fine. This double equal is useful for primitive type. Let's say if it is 10 here and t is equals to 10, then if I would have used s equals to t, then we will get true always. So I hope you got it. So I hope you understood why it was working for 127 and 126. Why not for 128? This is an interesting concept to know because this will give an information like what libraries does to optimize and give better performance sometimes. Let's move on to the next question. So the answer is, as you know, for minus 128 to plus 127, it will reuse the objects for the performance optimization. Values beyond this range, integer will create new objects and it lead to return false result. So because of that, we got the false result for 128 comparison. I hope it's very clear to you. Let's move on to the next question.